Hello guys, welcome back to my channel. Today's topic is about sequencing problems in Johnson's model and jobs with any two missions. First, we know there was a meaning of sequencing problem. See, the selection of an appropriate order for n number of any different jobs to be done on n number of missions is called sequencing problem. See, in the last video, I taken the example of ice cream manufacturing. For me, for ice cream manufacturing, they have the 7 different jobs. So based on the jobs, we are assigning the jobs to an emissions. So here also, the selecting of an appropriate order for the job and assigning the jobs to an emission is called as a sequencing problem. See, before starting the in jobs with any two mission problem, let we know the was terminologies we are going to use in this in jobs with any two missions model. The first terminology is in a processing time. See, suppose for an example, there is an mission one. So here and mission two. So this manufacturing unit, they are using the two missions. One is in a mission one, and another one is in a mission two. See this for in a production, first they will give the inputs and the mission one do the process, and once the mission one process was completed, then it will go for any mission two. The mission one output it's become as an input for any mission two. So once the raw materials was given to the mission one takes the 2 minutes of any time for process. Once this process is done, then only it will send to the mission 2. Means here the total time taken by the mission 1 for completing the task is called as a processing time. Here the time required by a job on each mission. And second terminology is about processing order. See, most of the job shop production systems, once they receive the order from any customers based on their order requirement only, they can schedule the jobs to any missions. The same thing here, it is an order in which missions are required for completing the jobs. And the third terminology is about an idle time on mission. See here, first we given the input and the mission 1 will process it, and then only it's sent to the mission 2. So here for a processing time of an mission 1 is only 2 minutes. So here the mission was doing process for only 2 minutes. So until that process was complete, the mission 2 must be in calm. There is no work for mission 2. Why? Because the mission 1 output becomes as an emission 2 input. So here the 2 minutes is any calm period. That calm period we can call it as any idle time on mission. See, it is in a time for which a mission does not have a job to process. That is idle time from the end of any job. And the third terminology is a total elapsed time. See, for the example, the same thing, the mission 1, it will take the process time of any 2 minutes, and the mission 2, it's take the process time as any 5 minutes, and then it's next, the mission 3, it will take the process time of any 5 minutes. So here, the raw material was going into the 3 missions, 1, 2, 3 missions. So if you want to get the final output, means finished product, means the total time will taken by the missions or 2 plus 5 plus 5, means it's a total 12 minutes time was taken by the mission for any completion of any task. So here the total elapsed time is, it is a time interval between the starting the finished job and complete the last job. See, it includes the idle time in order to by given the set of missions. So these are the terminologies in job sequencing problems. In the next, we have any assumptions in sequencing problem. The first assumption is the no mission can process more than one operation at a time. So here once the input we given, that mission wants to process that task only. So we can't assign the more tasks for any mission at a at the same time. And the second assumption is any the each operation once started must be performed till it's complete. And the third assumption is a job is an entity, means that is every thought the job represent a lot of individual parts. No lot may be in a process by more than one machine at a time. And the fourth assumption is each operation must be complete before any another operations, which is must processed can begins. And the fifth one is any time intervals for processing or independent of the order in which operations are performed. And sixth one, a job is a process as soon as possible subject to order requirements. And the seventh last assumption is all jobs are known and are ready to start process before the period under the consideration begins. So these are the seven assumptions in sequencing problems. Now we will see one example problem which is related to the in jobs with any two missions. So the question is like this: there are 9 jobs, each which must and go through the two missions. The missions are P and Q, and the order is P and Q. Means first mission is an a P and second mission is an a Q. The processing time is in hours, and the times are like this. So based on this information, we want to find the total elapsed time, means total processing time of mission A, means mission P and mission Q, and the total idle time means the missions which are calm, means without any work. Okay, so based on this information, we want to do the end jobs with two mission problem. So here there was a main use of doing this method, means here by based on this method the production managers they can able to um, know there was a sequence of an emission, sequence of any jobs. Based on that sequence they can able to know there was a total elapsed time, means total processing time of these all jobs. Okay, so first we'll start the solution. The first step is we want to identify the least process time job, means the smallest process time job in the two missions. So here we having the two jobs, like 9 jobs, and the missions are P mission and the Q mission. Okay, so we have the 9 jobs, so I was taking the 9 columns. Okay, here if you identify the minimum time, means smallest processing time in mission P, means it is in mission 1, means the smallest processing time from mission P, means we will write the job, these are the jobs, the job sequence from left to right. If you identify the least job, means least time job in the mission 2, means it's an Q mission, means we will write the job sequence from a right to left. Okay, like this will identify the each will identify the minimum time, means smallest time from all 9 jobs, and based on the time factor we will record their jobs in that sequence. Okay, so now we will do the first, the minimum time here in this chart is any 2 hours. That's 2 hours from any mission P. So this is any job A. So 2 minutes from any job A and the mission was P. So if you identify the smallest process time from an mission P, means we want to record it from left to right. So the job name is any A job. So I was placing the job from left to right. And here now I was eliminating this job. And the remaining jobs, the minimum time job is any 3. So here E and job G, I think so. Yes, from I identified the 2 jobs, it's an E job and the G job. Okay, so these both jobs are from mission Q. it's in a second mission. If we identify the least processing time from an mission 2 means we want to record it from the right to left. So here we have the two jobs is any G and E. So G and E. Okay, G and E also we are eliminating. Okay, next we have the process. The next, the least process time is in a 4. 4 from job C, and next from job D, it's in a mission Q, and next 4 from I, it's in a mission 1. So here this is I from mission 1. So it's in a left to right. So I was placing this I jobs on the next to A, and the next job, so I eliminating this I job, and next here the fourth one is in the D. So D job in the mission 2. Mission 2 means it's just right to left. So I was placing this job next to the E job. So E job. And the next we are having the Cth job and the mission from E. So I was placing it on next to the I job. And the next here I was eliminating this C job also and the D job also. Yes, next we having once the 4 is done, the minimum, the least processing time is 5, and I identified this job from B. Okay, it's in a B job in the mission 1. So I was placing this, it's in a first mission, no? So I was placing it from the left to right, next to the C. So I was eliminating this B also, and next the fifth one was I identified in, it is in a H job in the P mission, means it is also first mission. So I was placing it from left to right, so next to the B. And the final H is also I was eliminating. The final remaining job is an F1, so I was placing it. So we got the sequence of any jobs or like this: A, I, C, B, H, F, D, E, G. This is the job sequence. Okay, so based on this job sequence, we'll process to the next step. So next we want to take the columns. So columns are like this. It's in a job sequence, one column, and for an mission P, mission 1, time in column, process time column, and timeout column. For the mission Q, same thing, time in column, process time column, and the timeout column. And the final is any idle time column. See here, suppose if we given raw material to any machine 1. Here everything, the first input of any materials to an emission will calculate with any 0 seconds. Even our day also will start with any 0 seconds. Okay, yeah, once 0 completed, then only 1, first second, second, third, fourth, like this we have it. So here also we will calculate the in time from 0. Yeah, and next we have the process time. So here we have the process times like this. For an emission P, we have the 9 jobs and their processing times, and for the emission Q, jobs are 9 and the processing time are 6, 8, 7, 4, 3, 9, 3, 8, 11, like this. Okay, so based this information we want to know the was the total elapsed time and the idle times of any both mission. So we have the job sequence. We already done that sequence, so I was placing that sequence in a sequence order. It's an A, I, C, B, H, F, D, E, and G. Yeah, now I said that it's in every input it will starts with a time of an Z. Our birthday also will calculate. If suppose if the 12 is completed, it starts with 00 is started, means our birthday day was, we are in our birthday. So here it's in everything will starts with a 0, so 0 time. And here first for any A mission, here the A, sorry, it's an A job. For an emission 1, the process time is an 2 hours. So process time for any A job is any 2 hours. Okay, so we place the 2 hours in the process time. If we add the in time and the process time, we'll get the time out, means out time out from any mission 1. So it's any 2 hours. So we given the input for any mission 1 at 0 second, and that mission was processed the function for any 2 hours. Once the function was completed, that material was came out at any 2 hours itself. So this is the 2 hours as any time out period. Okay, like this we'll do for any all remaining 8 jobs. So here one thing you wants to remember, the time out of any X mission will become as a time in for any next mission. Yeah, once if you have one item, once that item was completed, then only we can able to once we have it, once the achieving was completed, then only we can able to give the input. Yeah, the same like this also, once the mission was completed his first job task, then only once it will take the 2 hours, means once the 2 hours was completed, then we'll give the next task. Once the 2 hours completed, again we'll give the next task. We can't assign the task within the same time. Once the task was completed for a certain period, after that period only we want to assign the next task. Yeah, next job is an ith job. So here the second job will become as an in time for any, sorry, second out time is become as an in time for any ith job. So here we have any ith job, and from any mission 1 it is in a processing time is any 4 hours. So time out become as an in time 2 hours, and the processing time is in a 4. If you add 2 plus 4, we'll get the 6 hours. Yeah, same thing, the time out will become as an a time in for any next job. Yeah, and next job is an a C job. The C job, the process time is an a 4 hours. So 6 plus 4, 10. So don't confuse students why I was taking 4, why not 7, means now I was entering the process time for mission P. So for that sake only I will take only this, I'm considering only this row only, this row only. Okay, and next here the out time will become as an in time for the next job, and the B job processing time is any 5 hours. Okay, 10 plus 5 it's any 15 hours. Again same, the out time will become as an in time, and the job is any H job. The H job processing time is any 5 hours. So 15 plus 5 it's any 20. The same thing 20, the F job processing time is any 8 hours. 20 plus 8 is any 28. The same in time will become, sorry, out time will become as an in time, and the processing time for an mission D is any 9 hours. 28 plus 9 it's any 37. And next is any E job. The out time will become as an in time, and the E job processing time for an emission P is any 6 hours. 37 plus 6 will get as any 43. And next job is any G job, and the 43 will become as any in time for the G job, and the processing time is any 7 hours. So here 43 plus 7 will get the 50 hours. So this is a total process time for any mission P. Yeah, and next we will do the same process for any mission Q. Here the mission 1 out time will become as any mission 1 in time. Yeah, mission 2 out time will become as any mission 2 in time. Mission 1 out time will become as any mission 2 in time. So this is a mission 1 out time is any second hour. Yeah, this processing time of any A job with any Q mission. Now I'm considering this Q mission row. It's an 6 hours. 2 plus 6 will get the 8 hours. See here, again here we want to cross check once. So here for any processing time of any job A for mission Q, it takes the 8 hours. means total process of any eighth job. Total process of any eighth job. Sorry, total process of any a job. So it's in a total 8 hours. So here the next job they wants to give the input for any mission 2 means here the this job and this present means mission 2 out time job. First we wants to compare. So here if you compare means and you wants to consider the maximum one. So why? Because here the task was completed at 6th hour. In the 6th hour itself we can't able to give the input. Why? Because the mission 2 was still processing the job 1 itself, means job A itself still process is going on. So the process is going on, so the simultaneously we can't able to assign the task or job to any mission. So what we'll do means we'll wait for until mission 2 complete his job. So the mission 2 was completed his job at 8th hour. So now what we'll do means we will give the input to an 8th hour. Suppose the mission 2 the processing time the timeout time is an 6 and the here the processing time for an 8th job is an 8, just for an assume. So here the maximum one is an 8. So here once this task, either job task was processed in mission 1, it's completed at 8th hour. So here once the 8th hour was completed and mission Q was completed its job at 6th hour itself. So here what we'll do means here we will start the next job here as an 8th hour. You got the point? Why? Because we can't able to assign the number of jobs to any one single mission. Here we want to wait until the mission task was completed. So for that sake what we are doing means we are considering the maximum time, means maximum time of here the mission 1, sorry, mission A and job A and job I. So here the job A1 is any timeout is any 8th hour and the job I time is any out time is any 6th hour. So compared to this both the maximum time is any 8th hour. So now I will give the input in time as any 8th hour, and the same thing the processing time for the 8th job is any 11 hours. So 8 plus 11 it is any 90. Yeah, the same thing again we'll cross check here. So here again we got the maximum time is in a 19. Suppose if you got the maximum time here means, so we'll write the in time as an a, the same thing means it's an e job out time will become as an a in time of an a mission Q. Yeah, the same here is a maximum is an a 19. So I was making it as an a 90 and the processing time for any e job is an a 3 hours. So 19 plus 3 it's an a 7, it's an a 26. Timeout is an a 26. The same thing again here 15 and 26 cross check. The 26 is an a maximum one. So to take 26 and the processing time for an mission B is an a 8. So 26 plus 8 it's an a 34. Again do cross check from here to here means is a mission 1 to mission 2 P2 Q. So 20 and 34. 34 is in a maximum one. So we'll give the in time of an 34. So and the processing time of an H job is an 8 hours. So 34 plus 8 will get the 42. Again cross check, take the maximum one, it's an a 42 and the processing time for an F job is an a 9 hours. 42 plus 9 will get the 51 hours. The same thing, compare, take the maximum one, 51 is a maximum and the processing time for any mission D is a job D and the mission Q is a 4. So it's a 51 plus 4 will get the 55. Again you'll compare with an out time of an mission 1 means mission P and the mission Q, the maximum one is a 55. So take it and the E job processing time is an 350 5 plus 3, it's an a 58. And the next again compare, it's in a 50 or 58. So maximum one is in a 58, take 58. And the processing time of an AG job is an a 3 hours. 58 plus 3, it's an a 61. Means total elapsed time, total processing time of mission P and mission Q is an a 61 hours. Yeah, mission P and mission Q is an a 61 hours. So total we complete these all jobs in 61 hours. Okay. So here first we want to identify the idle time, and next we want to identify the idle time. So here see, the idle time means the missions without any work, the time of the missions without any work. So here you observe here it's an a 0 plus 2 and the 2. So here the mission Q was calm for any 2 hours until the mission 1 was processed his work. Until that time the mission Q was waited for any input. So this will become as any idle time for any mission Q. So here again you can cross check 8, 19, 19, 26, 26, 34. Here like this 34 and 34. Just one second. See 34, 34 means out time will become as an in time. 42, 42 means here it indicates that the mission 2 was not in idle. So here in the first job A itself only the mission 2 was idle, remaining all time it was doing work. So total idle time of any mission Q is any 2 hours. Okay, now we want to know the idle time of any mission P. Simple, if we have the total processing time of any mission P and the total processing time of any mission P along with any Q. So if you subtract this mission total processing time with any processing time of any P will get the means 61 minus 50 will get the 11 hours. So 11 hours is any idle time for any mission P. Means here 61 hours still the mission 2 was working, but at the 50th hour only the mission P was completed its task. So here the difference of the processing time of mission Q and the mission P is an 11 hours. So the 11 hours was become the idle time of any mission P, and the final one is any total elapsed time. So total elapsed time is any 61 hours. Okay, this is the method of end jobs with any 2 missions. Okay, I hope everyone you understand this method. Okay, thank you for watching my video.